Welcome to today's Explainer. Today, we're tackling a thoroughly modern frustration, one that literally affects every single person with a digital device. We are demystifying software flaws by breaking down the anatomy and classification of software defects. We're going to dive right into the foundational concepts that explain why our software sometimes just flat out refuses to do what it's supposed to do.
I mean, ever had an app just instantly crash right in the middle of something super important? Or maybe you're clicking a button online and it just completely refuses to work. Yeah, we've all been there. It's incredibly frustrating. Well, today, we're taking that totally infuriating concept of a glitch or a bug, and we're breaking it down into an exact, structured taxonomy.
Okay, let's dive into this. Here's our roadmap. First, what is a software defect? Then, expectation versus actual reality, user-facing software defects, system and security defects, coding and logic defects, and finally, why finding defects matters.
All right, starting off with Section 1, what is a software defect? Let's establish our baseline.
So fundamentally, a defect is a problem or a flaw in the software. But, the absolutely crucial part of this definition is actually the second half. It causes the software to act differently from what was expected. Basically, this means the software is failing to follow the given requirements or the logic that was set out for it. It's not just doing something objectively bad, it's doing something entirely other than what it was specifically instructed to do. To bring that formal definition down to earth, let's look at a few everyday examples. A defect can be a button not working. It can be an app just crashing completely. Or it can be the software simply showing the wrong information. These are all literal instances where the software is acting entirely differently from what we and the developers expected. The requirements? Yeah, they just weren't met.
Moving right along to Section 2, expectation versus actual reality.
So the crucial point is that a defect is really just an error that makes the actual result different from the expected result. That gap right there, that invisible space between what was intended to happen and what is actually happening on your screen, that is exactly where the defect lives. Pretty much everything we classify from here on out is just a different flavor of this exact discrepancy.
And where does this expectation gap even come from? Well, our source outlines 3 root causes. Defects can happen because of design mistakes, coding mistakes, or logic mistakes. Somewhere along the very complex line of creating the software, an error in one of these 3 areas basically planted the seed for that actual result to veer wildly away from the expected result.
All right, Section 3, user-facing software defects. Let's rapidly categorize these, starting with the ones you experience directly.
Now, what's really interesting about this slide is that a functional defect is the most fundamental failure of a software's real purpose. This happens when the software just does not do what it is supposed to do, because the behavior simply doesn't match the given requirements. Look at it this way. If a calculator app adds 2 and 2 and gives you 5, well, that's a functional defect. It's totally failing its primary job.
But hey, it's not always about outright failure. Take a performance defect, for example. This occurs when the software is painfully slow or takes way too much time to respond. Like, it might eventually get the math right, but if it takes 10 minutes, that's a defect. Contrast that with a usability defect, which happens when the software is just, well, difficult to use or not user-friendly. It functions, it might even be blazingly fast, but if you can't figure out how to even navigate it, that's firmly classified as a defect in its usability.
Let's keep moving. Section 4, system and security defects. We're shifting focus here from the surface level straight under the hood.
Now, this is one we absolutely have to take seriously. A security defect occurs when there's a weakness or a vulnerability in the software that can cause security problems. We're not just talking about an annoying crash anymore. This is a flaw that could potentially leave the software and all your sensitive data inside it totally exposed. It's a critical gap in the expected versus actual safety of the program. Next up, we have compatibility defects. Have you ever wondered why a program works beautifully on your friend's computer but fails completely on yours? Yep, that's a compatibility defect. It happens when the software fails to work properly with certain hardware, other software, or specific operating systems. The software itself might actually be coded perfectly for one environment, but it totally clashes when introduced to these specific external elements.
And closely related to that is the interface defect. This happens when there's a problem connecting or communicating with another system or component. Think of it like a broken bridge.
Two totally separate systems might be working perfectly fine on their own, right? But the interface defect completely breaks down that absolutely crucial communication pathway between them.
Let's move to Section 5, Coding and Logic Defects, and see how this builds. We're drilling all the way down to the programmer's keyboard here. And this brilliantly illustrates two very distinct coding problems. First, you have a syntax defect. This occurs strictly due to typing or coding mistakes made by the programmer. It's essentially just a typo in the programming language. No big deal, but it breaks things. On the flip side, a logical defect happens when the software actually runs. There's no typo stopping it, but it gives wrong results because the logic or reasoning in the code is incorrect. The computer is doing exactly what it was told, but the actual human reasoning behind the instructions was flawed from the start.
Finally, Section 6, Why Finding Defects Matters. Let's slow down a bit to capture the overarching takeaway of our explainer.
It really all comes back to this core truth from our source material. Finding and fixing defects helps improve software quality and reliability. Every single time a developer tracks down a syntax error, or patches a scary security vulnerability, or streamlines a clunky performance issue, they are closing that gap between expectation and actual reality. They're directly elevating the quality and the reliability of the digital tools we rely on every single day.
So I'm going to leave you with a question to ponder as you go about your day. How will the software you use today achieve this reliability? The next time you open up a favorite app, send an email, or even just play a game, take a second to think about all the invisible defect hunting that went into making it run so smoothly. Thanks so much for joining me for this explainer, and keep your eyes open for those fascinating gaps between expectation and reality.